Good evening, everyone, and welcome to this session about XNA Game Studio 4.0. My name is Brecht Katz. I'm a lecturer at West University in Kortrijk, where I teach in the game development curriculum called Digital Arts and Entertainment. And I'm here today to tell you a little bit about XNA Game Studio 4.0, which is the latest version of XNA. Since it's the last session of the day, I kept it quite light. Normally I do live coding, but I won't do that today. I'll just show you what's new and end with some examples of games my students built to show you what's possible in XNA in a small time period with limited people. Okay, so the biggest new thing in XNA 4.0 is actually in the title. It's a new platform, Windows Phone. In the older versions of XNA, you could build games for Windows and Xbox 360. In the 4.0 version, they added a new platform, Windows Phone. Okay, so developing games for Windows Phone 7 using XNA, you can build more than 2D games. You can also build 3D games on Windows Phone using XNA. You don't have to use any unmanaged code, so it's all XNA C#. And performance is quite impressive. It's still a limited platform, so you have to manage all your resources pretty well. But games run smoothly. Games are easy to write, test, and deploy because you're using XNA and C#, which is a managed environment. And the game creation process is exactly the same as if you were creating a game for PC or Xbox 360. You can also easily convert PC games or Xbox 360 games to Windows Phone games. It's right-click on your solution and convert to Windows Phone game. There's a little but. When XNA was launched, I think it was in 2006, they said you can build your game once and deploy it to Windows and Xbox, which was quite correct. Now you can still make your game once, but you'll need to adapt your graphics, your 3D models, to work on the phone. Because if you use big models, which are no problem for PC or Xbox 360, they won't work on phone because it has lesser hardware and more restrictions. But more on that later. I'm going to talk about phone-specific features for a while, because it is the biggest new thing in XNA 4.0. You can now build XNA games which integrate with the touch capabilities of your phone and accelerometer. Your phone does support shaders. Does everybody know what shaders are? No? Okay, so if you have a 3D model in space, you want it to be visually attractive. You want texture on it, normal maps, put color on it. You do that via shaders. Shaders is a programming language or program that runs on your graphics card that draws your 3D models. This is a known custom language. XNA uses HLSL, which is high-level shader language. And Phone does support it, but you can't write your own shaders. You have to use one of the 5 built-in ones. I think the reason is performance, because probably building shaders for a phone isn't that easy. And Sean Hargreaves said in one of his presentations that they had to do quite some driver hacks to get things working. But you can use shaders, just don't make your own. Another thing that's very different from XNA on PC is that the update on phone is called 30 times per second, while on PC you update 60 times per second, which is mostly done for games. But most of you won't notice that when building for phone. Okay, so obviously a phone doesn't have a keyboard or a mouse or an Xbox controller. but Windows phones do have touch capability. You can touch the screen, do gestures and stuff like that. Now, you might think that programming or implementing touch features is quite hard, but it really isn't. It's very similar to the way all other input devices work in XNA. For instance, if you have a gamepad and you want to get the current state of the gamepad, you can just call gamepad.getState. Touch works very similar. You have a static class touch panel, which has a method getState, and you can call the state, call it to get the current state if there is any touch input on a device. What's cool about that is that it supports gestures, and you can actually use gestures in your game. For instance, you have dab, tap, double tap, you can pan, you can flick things away. For instance, if you were making a game, let's say side-scroller, enemies were hunting you, trying to kill you, like you could kill them by jumping on them, shooting them, but you could also kill them by flicking them away. You have touch and hold, you have pinch to zoom in, zoom out, and stretch, of course. So you can use these features for making your game better. Because it has this support for gestures, it also opens other capabilities. For instance, I had a student which made a game for PC, an XNA game, but his controller was his phone. He connected his phone to his window games, and with touch made a controller from his phone. And everybody could, everybody, 4 people could join using their phone, playing the game with their phone as controller. There's also a Microsoft demo out there from an application using Kinect and Windows Phone, where one player is shooting a ball at a goal using his phone with gestures, and the other player is standing before his Kinect device and trying to catch the ball as keeper or goalkeeper. So it does open a lot of capabilities. Another phone-specific feature is the accelerometer. All Windows Phone devices have an accelerometer. They don't have a gyroscope. But you can measure acceleration in 3D. So you have 3 axes, X, Y, and Z. You can measure the acceleration, and you get values between -1 and +1. The odd thing about this is that, in the contrary to all other things in XNA, it's event-driven. So for touch, you just have a class where you call getState. For the accelerometer, you have an event-driven model, because it's actually the same as Silverlight's model. So this is just an illustration of how it works. So you have 3 axes, and you can get your values between -1 and +1. For instance, when do I have my mouse? On the right side, you see +x. X is negative when this edge is up. So it just shows you which values you get. Okay. When you make a game for Windows or Xbox, you always have a fixed screen resolution. Your TV you don't have a fixed resolution, you have a fixed orientation. You probably won't turn your TV at home, just turn it sideways, you won't do that. With a phone, you can do that. And you can actually play a game in different orientation. You can play it in landscape, top right, or landscape the other way around. Not all games support this, but you can tell XNA which orientations you support. You can do this via the 3rd line in the game1 constructor. So there you say graphics.supported orientations equals, in this case, all possible orientations. So you can play the game holding your phone however you want. You can also play with that when you build a game. For instance, today there were exams. Students had to come and present their game. And there were students who made a game for children with chicken. And you had to switch gravity in order to conquer a maze and get to the end of the level. They did that with phone. You had to turn your phone to, well, manage your way through the level. Seeing if, or getting to know if the orientation of your phone changed is also event-based. So there's an event orientation change which you can subscribe to, and then you can handle the codes to draw your game differently depending on the orientation. Also very important is the scalar. Windows phones all have similar specifications. For instance, the first phones who came out all had a resolution of 480 by 800. You can write your game using different resolutions, for instance, for performance reasons. You can write your game for smaller resolutions, for instance, 240 by 240 or another resolution, and the scalar will make sure that your game is still drawn full screen, by using the hardware. So there's no performance impact by upscaling your game. So this is a neat feature if you want to gain performance, because not all games run at the 800 by 480 resolution without the glitches. That's for the phone specific features. XNA 4.0 also has a simplified graphics interface. They have two profiles, one called Reach and one called High Def. And this profile will actually dictate what capabilities your game will have. For instance, Reach is supported on phone, but will have limited capabilities. High Def will use platform features specific to that platform. You'll be able to use features from the Xbox or from PC, but High Def doesn't work on the phone, of course, because it just isn't powerful enough. So you can easily switch between these settings and determine which capabilities you use. I don't know if you guys can read this. I've put a link at the bottom of the presentation. This is actually a table by Sean Hargreaves, which mentions the differences between the Reach and the High Def profile. For instance, Reach works on Phone 7, Xbox 360 and PC, while High Def only works on Xbox 360 and Windows PCs with DirectX 10 GPUs. Also, the shader model in the Reach profile is 2.0, while in High Def you can use 3.0 and all features. There are some more items here. I'll just find some interesting ones. For instance, I don't know if there are any guys here who often write games or tried writing games. Has anybody ever written a game? One person, not that much. If you build a game and you have models, each model has a texture, which is the colors of the model. When you build models and textures in the High Def profile, they don't really care what the size of your textures are. But if you build for the Reach profile, your textures has to be a power of 2 size or equivalent. The size has to be 512 by 512 pixels or something like that. What else is interesting? You don't have multiple render targets. For instance, if you have a race game, and in the race game you have a rear view mirror where you can see what's happening behind you. They do that by using multiple render targets. They render the scene twice. You can do that in High Def profile. You can't do that on phone. What else? The rest is more technical, but you can look at this yourself if you want to. The link is below, and there's a lot of explanation. Okay, then I told you that the phone supports shaders. You can't program shaders on phone, but you can use 5 built-in effects. And you can do a lot with them. They have 5 effects: the basic effect, the dual texture effect, alpha test effect, skinned effect, and environment map effect. The cool thing about this is that the source code is available. So I'm going to show you. If you go to the App Hub, the link is at the end of the presentation, you can download the source codes for the shaders they've written. For instance, the basic effect shader, you can open the FX file, which shows you the HLSL code. And you can see the C# files as well, so the C# implementation. This is very interesting if you want to see how the XNA team did stuff and handled performance. I do advise you, if you look at this code, don't start with basic effect. Even if it has the word basic in it, it's quite an advanced shader, one of the hardest to get, so start with a different shader. In this new release, basic effects also basic effect also has been heavily optimized. In old XNA, basic effect was quite slow. They didn't really care that it was slow because they didn't need all the performance. If you had complaints about basic effect, just write your own shader. That's what they said. But now, because you will often use it when building games for Windows Phone, they had to make sure it performed a lot better. So they updated it. What does basic effect do? It supports transforms, basic lighting, up to 3 lights, fog, and textures. For most of the situations, this will be okay. So it will be the effect you use the most. There are other effects like dual texture effect. Now, what does that do? If you look at a modern game, most modern games have a scene and they have shadows. Shadows aren't supported by the basic effect. And since you can't write your own shaders, it would be hard to create a game that has shadows. But shadows offer a better looking game, so most people want them. And that's why they have the dual texture effect. It's a shader that takes 2 textures and kind of blends them together. For example, the first texture contains the color and the detail of an object. You could also bake in some sort of specular. And the second texture contains lighting information. When you put them over each other, you will have shadows. Not real-time shadows, because the shadows won't move as I move, but for instance, for the chairs and with fixed lights, it's okay. It's also a technique they used a lot in older game engines and still use it. That's called, well, baking your light. Then you have an alpha test effect, which does kind of what its name suggests, alpha testing. So it's kind of implements transparency. Then very interesting is the skin effect. If you want to do animations, it sounds simple, but to implement the code yourself, it's actually quite hard because there's a lot of math in it, and most people don't like math. Maybe some of you do, but trust me, most people don't like it. My students don't like it. And this shader allows you to do animations, skinned animations. On the App Hub website, there's an example from a character, a person, which walks around, so you can do character animations, you can use other animations. It supports up to 72 bones with 4 weights per bones. If you don't know what a bone is, well, let's put it as a section of your skeleton that can handle movement. Okay, and then you have the environment map effect. It also has a diffuse texture to store the color of your object. And it has a cube map texture containing an environment map. Now, a cube map is an image, a texture, which contains all the data of the space around you. For instance, if I had a cube map of this space, you could see it as the space here, unfolded in like a cross, with every angle on a part of the texture. You can use this effect to mimic reflections. For instance, reflections of the current environment, if you had a glass bowl or something like that. So that's why you use environment maps. Another new thing are the built-in state objects. If you are familiar with game programming, DirectX has a lot of states that have to be set. And you had to set them all manually. For instance, if you want to enable your Z buffer, I hope everybody knows what a Z buffer is or not. Somebody who wants to hear the explanation or not? Okay, one person. A Z buffer is a buffer. You can see it as an image, which determines depth in a current scene. So you can see if an object is further away or closer away than another object. You can handle these or enable and disable these via blend states. But you have to do it manually, or you had to do it manually. Now they created 4 classes, objects, that can handle these states for you, so it's a lot easier to update them. For instance, if you tried in XNA 2.0, as an example, if you try to mix 2D and 3D, often people had a lot of problems. Their 3D models became transparent. That's because the sprite batch, which you use to draw 2D images, changed a lot of states on the graphics card. Then you had to go and look which states does it changed, has it changed, and reset them manually. Or you had to pass save states arguments to the begin methods of the sprite batch, but then your application became slow, so it was kind of hard. And they implemented these 4 states to simplify that. So you can just adjust what you want. Okay, there's also enhanced audio support. You now have support for your microphone and dynamic sound effects. So you could actually take what the player is saying or the environment from the player as input via the microphone and real time do stuff with it to create another sounds in game. You couldn't do that before. Also, one special thing for the phone, it doesn't have support for Exact. Exact is Microsoft's cross-platform audio creation tool, which you can use to, well, play sounds, put effects on the sounds, and then play these sounds on Xbox or PC. In XNA 2, I think it was, they added other supports for sound, so you could just load the sound via new sounds and then play it via a play method. Because the Exact way was quite hard, you had to manage a sound bank, stuff like that. But this phone doesn't support Exact, and it also supports less voices or less tracks at the same time, because it still is a limited hardware device. Okay, I went through that quite fast. I'm going to show you some videos of games my students built. The reason I'm showing this is, first of all, because they are built in XNA 4.0. And second of all, they were built by students who never worked with XNA before. They worked in teams of 4 people, worked on it for about 10 hours a week for 12 weeks, so not that much of time. They did have a basic understanding of game programming, and they could model their 3D assets and stuff like that, but they had never worked with XNA. So, I'm first going to show you this video. And skip the menu. So I can show you the game. Okay, this is a game they have written for the Microsoft Imagine Cup, which is a worldwide competition by Microsoft for students. They made a game. It's quite simple. You have a plane, and you have to drop packets on certain villages. This project actually got into the finals of the Imagine Cup, and they can go to New York to defend their place, earn some money. So it's quite basic game. You have a plane. You can fly around on a 2D plane, so you can go up and down, and you can just drop packets. What does this have? It has physics. It has 3D models. It has landscapes. A plane you can fly, and it mixes 2D and 3D. All done in XNA, and if you're honest, it kind of looks like a game from, let's say, a couple of years back, and it kind of shows you that you can still do something nice looking with XNA. Because if I talk to people, I talk to a lot of people from the game industries, also bigger companies, smaller companies, and when I talk to them about XNA, it's always, XNA, it's a managed language, it's not C++, performance is going to suck, it's something for children, stuff I always hear. But you can see you can make nice things. Another thing that is cool is that in the new version of Silverlight, you can talk to your XNA applications. You can load an XNA library, 3D models, and display them in Silverlight. It doesn't support it the other way around, which is kind of stupid, because in games, all user interfaces, all these things you can see here, are done by images and manually applying effects to them via code. Now, professional game engines don't do it that way. They just use Flash and a product called Scaleform to load their Flash images in-game. It would be very cool if Microsoft did the same for XNA and Silverlight, because then you could make cool-looking user interfaces in XNA games instead of the other way around. Because if you load your XNA app in Silverlight, you won't have your updates method, that's called, every time. You won't have your tick, all that. So this is one video. I'll show you some others. Let's play this one. This is a game made for Windows Phone. It's a screen grab from a PC because they had some trouble doing it. Come on, play. Capturing it from the phone device. But it's a top view game where you have to move your way around the world and obtain some objectives. It has a quite interesting subject. It's about gender equality. So you have to move around without being seen, dress yourself up as a boy, because the main character is a girl. But if you look at this, it still looks quite nice to be a phone game. You have basic models, everything is in 3D. You can play cutscenes. Just skip along to see if I see something interesting. So you can see it's also quite a big world that works on phone. This doesn't really use any of the specific capabilities of the phone. It's just a joystick to move around. If you look at this white thing is your joystick. You can just put your finger anywhere on the screen and move your character. Okay. I'll show you another one. Here's another game for Windows Phone, which does use some extra capabilities. The idea is simple. You have to collect some berries that are in the bottom of the ocean. You can't hit the wall when you have the berries. There are fishes that try to catch you. The reason I'm showing this is because the entire world you see here is a physics world. Physics are quite heavy to calculate. They are also quite heavy on phone, but you can still see it works. Now it works slowly, but the game does run smoother than that. It also has more interesting capabilities. For instance, when you get an enemy, you can flick him away for killing him, stuff like that. So you can make really interesting games on Windows Phone. Now, if you say, hey, I like what I saw, I want to start building, flick it away. I want to start building games for Windows Phone. How do you start? For PC, you can develop games in XNA for free. For Xbox, you had to pay. It used to be $99 a year to be able to develop for Xbox and deploy your games to Xbox. For phone, you have to pay as well. But now it's one membership, $99. And you can then build your games for Xbox and for phone. If you're a student, you can go to DreamSpark, register yourself, and build games for free. So that's kind of nice. There are some limitations which I think aren't that great. For instance, you can deploy, I think it's 10 different applications to your phone once you've unlocked it, which isn't that much. You can only try 10 games and then it's over. Oh yeah, I have to buy a new subscription or another phone. But it's still quite nice. You can do it and actually build games for your phone and Zune. Another thing I want to show you is also something annoying. It doesn't work here because it's just compiled effect samples. But if you want to deploy a game to your phone or to the emulator, you have a nice emulator for Windows Phone. You don't have to deploy everything to your phone. So this is the emulator. I can play the game I just showed you on the emulator as well. So if you want to test on the emulator, you just have to build and deploy it to the emulator. It all happens automatically from within Visual Studio, but there's one little catch. For instance, here, where you normally have your platform where you want to build to for Win32, 64-bit Xbox, Windows Phone, you can see the Windows Phone 7 device, but it's grayed out. And if you try to build it, you will get a warning that the Zune software isn't started. The first time you encounter it, you will have something like Zune software. I don't want a Zune software, I just want to deploy it to the emulator. And that's because you have to enable another toolbar called the XNA Game Studio Device Management toolbar, which is this toolbar. And if you start a Windows Phone project, here you can choose if you want to deploy to the phone or to the emulator. It's quite annoying, and the first time you build games, you'll definitely overlook it. So if I go back to my emulator, you can see the game runs on the emulator. Yeah, whatever. You can move around. Let's see if I can go. So, and it does run quite smooth on the emulator, even though it's with heavy physics. In if you remember, I don't know if any of you guys developed applications for old Windows mobile devices. Developing for the emulator was, I shouldn't call it interesting, but it was a lot of work. The emulator wasn't that great. It was really slow. But this emulator actually works pretty good. You can't test your accelerometer on it, but there are some libraries where you can test it using the remote. So you can get beyond that as well. I also wanted to show you some resources for if you want to get started with XNA and especially Phone 7 development. First of all, we used to have the Creators Club website, which was creators.xna.com. It doesn't exist anymore. They moved everything to the App Hub. The App Hub is now create.msdn.com, and it's the place where you want to go for resources. For Windows Phone development, for XNA development, all that is now joined together. They also have forums which are quite active, where you can get feedback from game industry people, MVPs, and even Microsoft people. Sean Hargreaves, one of the people who's working on XNA, is very active on there, and he tries to answer almost every question. Next, there is a training course by Microsoft, an online training course, on Windows Phone 7. So you can look at that, and you'll get a crash course in developing games for Windows Phone 7. And there are also some interesting articles about performance, because, well, the first time, if you build a 3D game for the first time, it probably won't run as smooth as you want to, because it still is a limited resource device. But it has some great tips. And then a great place to look is the blog of Sean Hargreaves. He posts a lot of blog posts which are very interesting and give you a view inside the internal workings of XNA.